Today's lesson is on writing and solving two-step equations from word problems. Today we're going to write and solve two-step equations in one variable given a word problem. A typical two-step equation may look like this. Negative 3x minus 8 equals 19. We will use this pattern as an outline or a template to help us. So we're going to start here. What we will fill in next to the variable will be the coefficient. So we're going to write that. We're going to put coefficient. That's the number in front of the variable. It multiplies the variable. And that's going to be, we're going to look for a number written in word form or in the word problem that has to do with the variable. The next spot that we're going to try to fill in will be the constant. And even though it shows that there's a plus sign, we could be taking away a constant. So for the purpose of this pattern, we just have a plus sign there. It could be a minus sign. And then on the other side, whatever we have there will end up being the total, equals whatever the total is. So this is the outline, and that's what we're looking for. We're looking for a coefficient, number that's working with the variable, a constant, a fixed value, and then a total. We're going to read the entire problem and identify what we're being asked to find. Here's what's important. What is the question? We're going to underline it. Then we're going to choose a variable that represents this unknown quantity and write a sentence saying what this variable stands for. When we do that, that's called defining a variable for the unknown quantity. So they often call that defining a variable. So let's do that right now. Let's use our letter A as our first example. Maria went to Big Lots and bought a binder for $4 and 5 markers. She spent $9 altogether. How much did each marker cost? Well, we were asked to underline what the question is. So, how much did each marker cost? Now, based on what they're asking us, we're going to go ahead and step 1 said define the variable. And we often write it like this. Let whatever the variable is. In this case, we're trying to find out the cost of a marker. And we often use a variable that kind of resembles our, makes us think about what we're talking about. So I'm going to use an M for marker. And we're going to let M equal or represent the cost of each marker. At any point, you can pause and write this down. So now let's go back up to our step-by-step guide. Step 2 says, read the problem again and cut the entire problem. When we say cut, it means we're circling and underlying and trying some kind of strategy. So we're going to look for a number that can be used to multiply the unknown quantity. So a number that's working with our variable, and that's the coefficient. We're looking for a fixed amount, which is a constant, and we're looking for a total. And I believe that from my point of view, I think the total is a little bit easier to find, and the coefficient is easier to find because I'm looking for something associated with a variable. So now let's go back to letter A example and see if we can do step number 2. So step number 2 is going to ask us to use our template. I'm looking for a number that's a coefficient in front of our variable M. I'm going to put plus for right now, but we might end up putting minus. I'm looking for a constant, and then I'm looking for a total. So we're filling those 3 blank spots or boxes. So it asks us to read the problem again and cut through the information, circling important information. So Maria went to Big Lots and bought a binder for $4. So that's certainly important. She bought a binder for $4. Let's circle it. And it goes on to say 5 markers. Oh, sometimes they give us numbers in word form, so that's important. 5 markers. So even though they didn't write it as a number, a numeral, they wrote it in word form. She spent $9 altogether. And that altogether word is kind of a clue word that's going to be helpful. So I'm circling that. So we ended up underlining the question. Then we circled important information, and we're going to try this strategy of filling in this template. So right here, I think the fact they said all together, that's a pretty good indication that 9 is the total. And because the numbers that they're giving us are whole numbers, I'm going to go ahead and write it as whole number 9. So the total goes in this spot. Then, for me, the coefficient is a little bit easier to find because it's a number that is working with my variable. So M talks about the cost of markers. And when I look at this number 5, it's also referring to markers. There are 5 markers. So it would make sense if I wrote 5 times the cost of each marker. That would make sense. So by process of elimination, the last number that we haven't talked about is a binder. And that's a fixed amount. It's one binder, and that costs $4. So we're going to write 4 here. So now we have our equation. So I'm going to go ahead and write this and just make it so it's not within our template. So this is the equation we're working with. Now let's go back up and look at what our final step is to finish this up. Number 3 says solve the equation and answer the question in a full sentence. This time it's not just raw numbers. The answer is going to have meaning because it's a word problem. So what does the solution mean? So we've done this before. We've solved a 2-step equation. Let's work on this. So we're going to build our wall. I'm going to take away 4 because it says adding 4. Do the opposite. 5m is left over, and on this side I have 5. Then I'm going to divide by the coefficient on both sides. That's our second step. And the final answer is m equals 1. So they ask us to put meaning to what this 1 is. So this is where our defining our variable comes in handy. M represents the cost of each marker. Therefore, 1 must mean the marker cost $1. So we're going to write that in sentence form. So each marker costs $1. So now we have meaning. And I needed to look back and make sure that we were talking about dollars. So now let's go to problem number 2, and we're going to start this process one more time. For a field trip, 25 students rode in cars, and the rest filled 8 buses. How many students were in each bus if 320 students were on the trip? So our first step is to underline the question and then define a variable. So the question is, how many students were in each bus? So we're going to let B represent or equal the number of students on each bus. Step number 2, we're going to try to fill in our template. We need a coefficient and the variables B. We're going to add or possibly subtract a constant, a fixed number, and then we're going to get a total. And if you prefer, you can put boxes here instead of lines, because this is what we're going to try to fill in if you feel more comfortable doing that. So now we have to go back and circle important information. Well, it said for the field trip, 25 students rode in cars. Okay, so those aren't students on the bus, those are students in cars. The rest filled 8 buses. So the rest filled 8 buses, and then how many students were in each bus if there were 325 or 21 students on the trip. Okay. So as I look at this, I'm looking for a number that is associated with buses. I'm looking for a constant, and I'm looking for a total. So this total for me stands out. That's a number that kind of stands out, and I know where it goes. So it's 321 total students were on the trip. Well, if I look at this 25, it mentions these students were in cars. So that doesn't have to do with my bus. So it does mention the rest filled 8 buses. And if we look back at our variable, I want to know the number of students in each bus, and there are 8 buses. So that 8 must be working with the variable. That's a coefficient working with the variable. So the 25 students, and of course, I know it's adding. Those are an additional 25 students were in cars. So we have step number 2 taken care of. And now step number 3 is to solve the equation and then state what our answer means. So we're going to write the equation without it being in the template or the outline, make it easier to work with. And now we're going to perform our solving steps. I'm going to take away 25 on both sides. The result is 8b, and this is 296. So now we're going to continue solving by dividing by 8 on both sides, and that leaves b equals 37. So we have our solution, but now we have to state what that solution is. And that's where we go back and look at our definition for B. Well, B is the number of students on each bus. So we now know that there's 37 students on each bus. So I'm going to write this clearly. There are 37 students on each bus. So we have answered our question. So what I'd like you to do is I'd like you to go ahead and try this last problem on your own, and after you've completed it, go and check back. Open up this video again or watch the next part of the video to see it solved and see if you agree. Thank you very much, and enjoy your afternoon.